Today we'll look at the problem number 146 on LeetCode. This is LRU Cache. This is quite a popular problem on LeetCode and gets asked a lot of places. So let's look at the problem first. So you construct an LRU cache using a capacity, and that sets the maximum limit. And then you try to do a get, and it returns you the key if it exists. If it doesn't, do a -1 and do a put with the key value and update the key value of the key if the key exists. Otherwise, add the key value pair to the cache. And if the number of key exceeds the capacity of the operation, evict the least recently used key. So this is what the LRU is all about. The condition here is that you need to do that in O1 time complexity, and there's an example of that. So you can see do a put of 1 do a put of 2 so at this point of time we have come close to the max limit of 2. So when you try to do a 1, it's going to be most recently used, so it's gonna basically 2 is least recently used at this point of time. So when you put 3 and doesn't find space to keep the entry, it's going to evict 2, and then that's what happens here. So you get the idea. Now this problem, I would say, is not very hard problem. It's LeetCode says it's medium. I think the main problem in this is when you write a code, you don't want this to get messy. So I'll try my best to write a non-messy code, and you can take a look at that and see if you like that or not. Also, I want to call out that this is a common problem that is already solved in Java SDK, which is basically linked hash map class, which does that. So basically there's already a solution for that. Meanwhile, I just want to call out that when you look at the solution, this is, you have a hash map, you can think of that, you can store, but the problem is you can you can call get and put in O of 1 because of hash map, but you cannot do the LRU part of the eviction in O of 1 by just maintaining a hash map. So you certainly need a secondary data structure. So one way to solve that problem, I mean, you can do in O of 1, O of n by iterating through all the members in the hash map. And that's certainly a brute force. So another approach, which is not very optimal, but it's log n approach, is you maintain a tree set. You add the key, and the value is like a node, an abstraction with the key value and the number of occurrences of access, and that's what can be used to sort it. So basically, depending on how the tree is constructed, you can have the least recently used here and the most recently used here based on the sorting. So you're going to be sorting based on the occurrences of access, and then you can figure out the leftmost or the rightmost from the tree to figure out which one needs to be evicted. So searching, adding, eviction, everything's going to be log n. So the downside of that is every operation is going to become log n. That's another way to solve this problem. Now going back to this problem, what we'll do is let's get rid of this. So in this problem, what we'll do is we'll have a key value pair in a map, and we try to maintain a doubly linked list, where doubly linked list is, this is the head and this is the tail, and we try to add the nodes in here. So all the nodes are going to be entry for certain key, and then this node, maybe this is this one, and it's closer to the head when it's either constructed or it's been recently accessed. So the idea is that anytime you access something recently, we would put it at the front in this list. While these nodes exist in the hash map, they just have doubly linked list, so they have linkages to the other nodes so that we maintain this list. So only thing we need to worry about is the one at the front and one at the back for removing the least recently. So the one here is going to be left out with the least recently used, and we would remove that. And removing it is easy if we have a tail pointer. So tail.pre is what this one is. So one more thing I wanted to call out is we wouldn't be initializing head and tail with a dummy node so that it's easy for us to write code and avoid checks like checking a lot of boundary conditions for null and empty and all that stuff. So with that, let's jump to the code. So before that, I'm gonna introduce a new class, private static class entry. Let's say private int key. Maybe I should make it key value, private entry next, private entry prev. Now entry can take int key and int value, and then this dot key is equal to key. So this is what entry is created with. Now I need to write a method to remove. Void remove. Or before I remove, let's come here and see why would we do that. So we need a map to store that information. So private final map integer as the key, and then the value is going to be entry. This new hash map private int max private entry head private entry tail. So let's initialize that. So map is already initialized, max is going to be capacity, head is new, and I'm just creating a dummy one because I just want to have a way to not deal with the null checks and all. Tail is new entry. So don't worry about -1 because when we access head and tail, we just say head.next and tail.prev. We don't really pay attention to that. And the good thing is if head is here and then all the nodes are going to be here, right? So you would never run into a scenario where tail.prev could be null or head.next could be null, because that's what we are going to add here. So what I'll do is I'll just say head.next is tail and tail.prev is head. So we created a condition like that. Now all the nodes are going to be somewhere in the middle. So this should be good here. Now let's go to the get. So when you do a get, let's look at the get, return the value of the key if the key exists. So let's see, entry is equal to map.get key. So if entry is null, then just return -1. I'm out of it. And if it's not, then what you do is entry does exist. So entry.touch, and I need to put it in the front, so I'll pass the head pointer and then say return entry.value. So this touch method is basically getting the entry to the front of the queue. And that's what I was thinking. So let's see, void touch entry head. So when I touch an entry, I'm gonna be moving it from the existing place and putting in front of head. So to remove an entry from some place, I'll just say remove first, and then I'll say move to head, and I pass the head pointer. So this is what the touch does. So I'll come back and implement that in a moment. Head. So you do that. Now this will take care of that. Now let's do put so let's see, entry is equal to map.get key. If entry is not equal to null, then you can say entry.value is new value, entry.touch, and then you would just say done from here. So let me make sure I did it right. So you touch the value, update the value. That's what it says. Update the value of the key, the value, the cache. If the number, so in this case we're not going to be exceeding capacity because we are just doing the same entry. Now here, when this doesn't exist, in this case what we'll do is we need to create new entry. So it's going to be new entry key and the value. Now what you do is you would add that entry, map.put key entry. Now entry.move to head, and that's it. So you just do this to head. We'll come back and check this logic. So remove. So if I'm removing pointer, so let's say head is like this, and I have E1 here, and let's say this is E2, and then this is tail. So let's say I'm removing E2. So for removing E2, what I need to do is I need to take this pointer and point to the next pointer. So this start previous dot next, I mean this pointer should point to the front of that, point to this dot next. So E2 dot previous E1 dot next should point to the next of this, which is E2's next. And we also need to make sure the pointer in front of that, the back of that, points to the one at the back. So then this dot next dot previous, E2's next previous, points to this dot previous, E2's previous. So now what happens is E1 starts pointing to E2's next points to tail, and tail in this scenario, tail, which is next previous pointer, this will start pointing to E1. So this should take care of that. And when we remove from here, yeah, so that's what we do. And the second one is when we move to the head. So let's say the same use case, I'm trying to add, let's say E1 here. So what I can do is, let's say if I'm trying to add 2 next to here, so head is pointing to something, so let's make this dot next point to what head dot next is, and then this dot priv should point to the head. This takes care of pointing to that. Now let's say if I was moving E2 from here, so E2's next is going to be pointing to head's next, and E2's previous is going to be pointing to that. Now in the front, head dot next dot priv should point to this, and head dot next should point to this as well. So now this makes sure that head dot next dot priv, E1's priv pointer should point to E2, and head dot next, which is this pointer, should point to E2. So that should make sure that this has moved to head. So this is that. Now that being said, let's see what happens. So move to head. Now once we do that, what may happen is we make seed. So let's see, if map size is greater than max, then basically we need to do eviction. So for eviction, we'll say remove from tail, and then that's it. So let's implement this method, void remove. Then let me pass that. No, I don't need to pass the tail pointer because it's the same class tail. So in this case, let's just go to the tail pointer, and then so let's say entry E is tail.pref, right? So I need to remove entry E. So going back to the same diagram, you need to remove E2 here. So tail.pref is E2, I saved E2. Now what we need to do is E dot, so E dot pref dot next should point to E dot next. So E dot pref dot next E1 in this case should point to E tail, which is E dot next, and so I made this pointer now the front, which is E dot next pref, which is tail. The back pointer should point to E dot pref, and we should also remove this. So map dot remove E dot key. I will also add a method public string to string, say return key is key plus, you know what, let me make it concise so that it's saving space and it's easy to look at. And then I'm also going to be adding a method here, void print, to print the head pointer. So let's say entry E is head, while E is head dot next, not equal to tail So now let's take a look at this, if it's correct or not. So we defined a hash map, we defined final entry, we defined the size of it, we head and tail. So we took care of the fact that LRU cache needs to have a capacity. So this is the capacity max. We're initializing head and tail pointer, and then let's make sure this is what it is. Head dot next should point to tail. So head is basically pointed to tail, and tail.pref point to head. So this is good. Now we're going to be filling in the middle. Now let's take a look at the get. Return the value of the key if the key exists. So let's take a look at the map.get key. Does it exist? Yes. So in this case, no. So we return -1. Now if it does exist, we're going to call touch on that. So it's going to put it in front of the head, like just right after the head, and then we return this value, and we'll take a look at that in a moment. We don't do anything else here. So making it clean. Now go to put. In the put, what you do is key value, update the value of the key if it exists. So look for from the map, get the entry. If the entry is not null, set the new value, do what touched that, so that you put it in the front. You don't do anything besides that. If assuming the entry is not found, you create a new entry, key value, and then put that into the map, key and entry. Now you move the entry to the next to the head. I'll go and check that. Now if map.size is greater than max, then you remove it from the tail, and they remove from the tail. Let's take a look at the method. So this is how it's going to be. So you want to remove E2 in this scenario. So entry, so you find E2 is the value. So tail.pref is E2. Now to remove that, say is previous, which is E1 next, should point to E dot next, which is pointing to tail, and then E next, which is tail dot pref, should point to E1 to E dot pref. So sorry, next tail dot pref, this back pointer should point to E dot pref, which is E1. So that's basically E1 is going to point to tail, and then tails previous pointers should start pointing here, and then we remove it from the map. Now, so let's take a look at the print head dot next. So because of the dummy pointer we created, we want to start from head dot next, and we want to stop before when it finds the tail. We don't want to print that. Now entry, final entry with key value touch. Okay, so for touch, and so the entry might be somewhere, so you want to remove that. So to remove the entry, let's say you want to remove E2. So you just want to make this pointer point to this and this pointer. So you would say E2 dot, in this case, if I'm trying to remove this, then this dot previous dot next should point to this dot next, and this dot next dot previous should point to this dot previous. So this should take care of removing it. And then to move to the head, what you can do is you have a head pointer, so you just say, you're trying to put something here. Let's say you're trying to bring E2 here, so what you'll say this dot next. So like you start pointing your pointer to what head is pointing at, so this dot net head. So you start pointing here to E1, and then the previous is next, so your pointer is basically here, and then you just point it to head and the next one. Now head dot next dot E1 previous should point to this, and head dot next should point to the new one. So this should take care of it. So seems like we can run this to test what's exactly is happening. So let's see. So what we wrote, okay. So we made a few mistakes. Let's fix that. Hash map and entry dot touch. So I called touch without calling the head. Okay. Okay, accepted. Shall I try to change the test case here and see? Let's say if I do a put here, so 3 gets, and then put, then say into 5 here. Maybe change this to, let's say 4 5. Will that change anything? Let me submit this. Okay, not bad. It's still over fun in the average time. One thing I wanted to call out, the print method I added, I've not used it, but I may be able to use that for debugging. So one more time, you basically create get put, and then you write a clean code by having everything inside the entry class. So I hope this helps. Thank you very much.